Hello, my name is Gary Arzumanian, and today I'm going to be showing you how to solve differential equations using Matlab using various functions like the dsolve function and the simplify function. Let's start by taking a look at our first function. We're going to be using a function called the dsolve function. This function is pretty simple. What we're going to be doing is inputting a differential equation, which we'll define after this, and then just putting as many initial parameters as you can. So initial parameter 1, initial parameter n, because you put as many as you want. So if you have a second order, you want 2 initial parameters. And also these are optional. You don't need the initial parameters. So if you wanted just to get just a general form, you just leave it there, and you'll just get the general form. So you can just delete it right here. And just do that, and that'll give you your original form. Okay, now let's take a look at a new form of notation we're going to be using to describe our differential equations using the symbolic toolbox. What we have to get used to is this formation, this dy. So when used in Matlab, this dy, this represents dy dt. Similarly, if you do a d2y, you'll get the second derivative of y with respect to t. For example, if you were to do dw, you'll get dw dt. So this notation is the one we're going to use, and also the d has to be capitalized, just like this. Now let's take a look at 2 more useful functions we're going to be using, called the simplify function, and we're going to use the pretty function. So the simplify function basically will take in our differential equation here, and we'll define our symbolic variable t. And it basically just takes in the differential equation, and when you run it, we'll simplify it into a more simple form. So here it just ran. So if we run the answer, we get 1. So this is a trig identity, sine squared cosine squared equals 1. This is going to come in really handy because when we use dsolve, sometimes it'll output a very complicated formula, and we can use simplify to simplify it down. Now the pretty function is another useful function, and what it does is it represents functions in much easier ways. So if you were to do, for example, sine t squared divided by cosine t squared, and run the pretty function, it'll display it in a pretty form. So much easier to see, so we'll be using this as well. Okay, so now let's take a look at an example here, applying everything we just learned. We're going to be doing the second derivative of y plus y itself, which is going to equal cosine 2t. So to do this one, let's go over into our Matlab window over here, and we start by using the symbolic toolbox to define y and t. After we have this, we're going to use our dsolve function. And let's start by putting in, remember with that notation, d2y plus y equals cosine 2 times t. And again, we need these little things right here. Close that, and now we should be getting our output from this. Okay, so notice here we get a long output just like this, right? This is usually what you'll get whenever you use dsolve. You'll get a big long output like this. And notice here, these are your constants, right? Because notice we didn't put in any initial parameters up here, because the question didn't ask for it. So now we can simplify this answer by using the simplify function we talked about. So simplify answer, and that will give us a nice simplified version, right? We can use now our pretty function to show it in a way that's more pleasing to the eye. And just like that. And here we have our solution, our general solution to the differential equation. Now that we've finished solving our general equation, I've put some initial conditions here. So at time t equal to 0, we found our initial conditions here are given as 0 for the first derivative and 1 for the original function. So now let's take a look at our dsolve back in Matlab. So this is our y of 0 equals 1, and our dy of 0 equals 0. And again, we just list them just in order like this, with comma separating them right after our original function. Let's press enter for this to see what it looks like. And again, as you noticed before, we'll get a big complicated function like this. And so after I run simplify again, it'll give us a simplified version, and I'll run pretty again to give us the final pretty version and the answer to our differential equation. So that is how you use Matlab to solve simple differential equations using the dsolve function and simplify and pretty functions. Thank you.